What's up, everyone? So today we're going to do SAT math, and our topic is going to be variation. So there are two different types of variation. One of them is direct variation and the second is indirect variation. So in this video we're going to cover both of those. Alright, so let's get started. Alright, so the first type of variation we'll be looking at is direct variation. Alright, so direct variation is always going to be in the form of y is equal to kx, alright? And k is our constant of variation. Constant of variation. Sorry for squeezing that in. So, sorry. So you'll be able to see what I mean when I go on to the next slide about what the constant of variation is and how direct variation is actually used. Because we'll be using an example to see what we want to do with it. Alright, so let's go on. Alright, so we have this problem right here. Water conservation. A dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water wasted varies directly with the amount of time the faucet drips. So, there are three things we have to look at in this right here. Let's move that up a little, and then let's start writing. So, we want to find the constant of variation variable and write an equation to model the direct variation. So, what we're doing is we are relating the following. The water wasted, so water, and then that varies directly, so I'm going to draw an arrow to time. So what we're saying is the more time that's being wasted, more water is also being wasted. And then let's also look back at the question. I'm going to see if I can highlight this. Alright. Nope, do not want that. Sorry for that. Can get rid of that. Alright. So you guys see how in the question itself, right here, it says varies directly with the water. It says the amount of water wasted varies directly with the amount of time the faucet drips. So let's go on and let us write the formula. Let us write a basic formula for how we can define this relationship. Alright, so let's go on to the next slide and we'll write the formula down. Alright, so we have this formula, we have this question here, same question from the slide before. So let's define a couple variables here. Let W equal to number of cups wasted, Alright, and then let's let T equal time in minutes the faucet drips. So time in minutes. Alright, so let's go back to this question that we had. We said water conservation. A dripping faucet wastes a cup of water, which means 1 cup. If it drips for 3 minutes, the amount of water wasted varies directly with the amount of time the faucet drips. Okay? So we can write a formula saying W equals K times T. Alright, let's go over this formula now that we have just created. So W is the amount of water in cups that it drips. T is the amount of time the faucet drips. And K is our constant saying how many, a constant factor which says, okay, if the water's dripping for X amount of time, and there is a K times K, you'll get that one water bucket, one water cup. So let's go on to the next slide, and I think it'll be more clear when I actually show you how it'll make sense when I show you how we do it. Started. Alright, so in the last slide we made the formula W is equal to K times T. So in our question, we said that 1 cup of water is wasted for every 3 minutes. So we can do this. We can set W to be 1 is equal to K times T. But we can actually also replace T in this case, because we're given that it takes 3 minutes. That's why we can say times 3. And the original question that we had was, we want to find the constant of variation. So if we divide both sides by 3, we get K is equal to 1 over 3. That is our constant of variation. And now let's go see if this makes sense in our formula. So let's go on to the next slide and we'll see if this makes sense on our formula. So we're given that we found out that K is equal to 1 over 3. Putting this into our formula, W is equal to 1/3 T. So in the question it says, for every 3 minutes, 1 cup of water is wasted. So let's plug in 3 for T. So W is equal to 1 over 3 times 3. Those cancel to be 1. So W is equal to 1 cup. So therefore we know that our formula does work. Our answer is correct. And we've done the right steps. So let's go on. So this video was pretty long as it was. So instead of teaching you as indirect variation also, I will teach that in the next video. So thanks for watching and have a great day.